Linear combination of sines and cosines. A linear combination of a sine and a cosine is an expression of this form: a cos theta plus b sine theta. Now what we will show is that this is going to be equal to some number c sine of some other angle alpha. So the key thing is you got to have the same angle for both cosine and sine. If this was 30 degrees and this was 60 degrees, it's not going to work. Now, if you have a and b are some numbers, so if a is 2, b is 3, then 2 cos theta plus 3 sine theta would be some number times sine of some other angle. But you can express this as a single sine function. And let's try to prove that. So here is what we are going to do. If I multiply and divide both sides, or if I multiply and divide the expression by a square root of a square plus b square, a cos theta plus b sine theta, then what I get, now let me move this square root of a square plus b square in the denominator inside the parentheses. And I'm going to rewrite it as a over square root of a square plus b square cos theta plus b over square root of a square plus b square sine theta. Then this is going to be square root of a square plus b square. And notice, I have a over square root of a square plus b square and b over square root of a square plus b square. So if I imagine a right triangle whose legs are a and b, let's say this is a and this is b, then this is going to be square root of a square plus b square. Now let's call this angle, let's give some name to this angle. So say this is say delta. Okay, then a over square root of a square plus b square is actually sine delta, and then I have cos theta, plus b over square root of a square plus b square is cos delta, and then I have sine theta. So the expression actually became square root of a square plus b square, and this is nothing but sine of delta plus theta, because sine of a plus b is sine a cos b plus cos a sine b. So you can see that what we just proved is a cos theta plus b sine theta is given by this expression, square root of a square plus b square sine of delta plus theta. So we expressed a linear combination of sine and cosine, or cosine and sine, by or as a single sine function. Now this is called the amplitude. The amplitude will be square root of a square plus b square, and there is a phase shift of delta. Here the angle is going to be somewhat, it's going to be different. So it's not just theta, but theta plus delta, and that delta is, so I can write here where delta is, you can see it's tan inverse of a over b.